we're going to discuss the difference between perfect squares and non-perfect squares and how to identify the side lengths of non-perfect squares. So here I've got 3 pictures of squares listed, and these would be considered perfect squares, and let me show you why. If I were to write the area of the square as 36, okay, I know that the side length of this square is 6 because the square root of 36 equals 6. It's a nice whole number. If this square has an area of 81, I know the side length is 9 because the square root of 81 equals 9. But what happens when you come across a square that's not a perfect square? And this would be an example of a non-perfect square, where the area is 20 and the square root of 20 is not a whole number. I don't get a nice number like 4. I don't get a nice number like 6. There's not a number out there that if I multiply it by itself, I end up with 20. So this is an example of a non-perfect square. And non-perfect squares are a little bit more difficult to work with because you're going to be estimating their actual value. Where perfect squares, we know right away what the side length value is of that square, based on what we know. Okay, so today we're going to take a look at some non-perfect squares and what are the strategies necessary to solve those. So what I'd like you to do is turn to page 101 in your book. I'll give you a couple seconds to turn to page 101 as I set this up. Okay, so we're going to be looking at the bottom half of page 101. So estimate irrational numbers using a number line. So here you can see we've got a square root of 8. So what they're basically saying here is that you have a square with an area of 8, and I want to know what is the side length of that square. Okay, so there is no perfect number out there. If I take the square root of 8, there's no perfect number out there that if I multiply it by itself, I end up with 8. So we have to do a little bit of estimating. So the first thing we're going to do is we're going to figure out, well, where does it fall on a number line? Well, here's what you can do. I'm just going to do this over here. So here is side lengths. Here is area. So if I had 1 squared, 2 squared, 3 squared, 4 squared, my areas are 1, 4, 9, and 16. And you can write this down inside of your margin. So here's my area. Well, also here's my area for 8. So where does this fall between in my areas? Well, it doesn't fall between 1 and 4. In fact, it falls somewhere between 4 and 9. So the area of this square is going to fall between 4 and 9, which means its side length has to be somewhere between 2 and 3. And that's what you can see here. This square root of 8 is going to fall somewhere on the number line between 2 and 3. Now, do we think the square root of 8 falls closer to 9, the square root of 9, or closer to the square root of 8? Well, 8 is closer to 9, so I know it's going to fall closer to 3. So I would say that the integer that the square root of 8 falls closest to is 3. So again, this would just be, oops, lost my pen. The answer here would be it's closest to 3. Okay, but it does fall between 2 and 3. So we're going to go through several examples of this. So if this is difficult or you're not quite sure what's going on, just be patient. We'll get through that. So take a look at the next page. So here we have an estimate of square root of 83. And I want to know, where does this fall between? What two integers does it fall between, and what is it closest to? So again, over here on the margin, here's what I'd like you to do. Let's start with 6 squared, I know is 36. And skip a space here just so it's neat. 7 squared is 49. 8 squared is 64. 9 squared is 81. And then finally 10 squared is 100. So these are my areas. These are my side lengths. So here I have the square root of 83, which is basically saying I've got a square with an area of 83. What is its side length? Well, it's not as easy. I know if I had a perfect square of 81, the side length would be 9. If I had a perfect square of 100, the side length would be 10. And I know 83 falls somewhere between there. So the square root of 83 is going to fall somewhere between 81 and 100, which means it's going to have a side length somewhere between 9 and 10. So this space here, the greatest perfect square less than 83, is 9 squared, and square root of 81 is 9. The least perfect square greater than 83, I guess this would be 81, sorry. This would be 100. Therefore, the square root of 100 is 10. So here again, they're saying that the side length is going to fall somewhere between 9 and 10. Now, is the square root of 83 closer to 81 or closer to 100? Well, 83 is closer to 81. So if you want to estimate, you could estimate something like 9.2 as an estimate. But it is definitely closer to the integer of 9 than the integer of 10. So therefore, I would say that the final answer is that the square root of 83's closest integer is 9. Okay, take a look at the check on the bottom. So again, here we have the square root of 135. So what you could do here, in fact, you should probably do it, is draw a little square with an area of 135. So over here in the margin, I know 10 squared is 100. 11 squared is 121. Write this down. 12 squared is 144, and 13 squared is 169. So where does 135 fall between? Now you can see it falls between 121 and 144. So I know if I had a square with an area of 121, the side length would be 11. If I had a square of 144, the side length would be 12. So that's how you know that this square root of 135 is going to fall between these two perfect squares. The perfect square of 121, perfect square of 149. So square root of 35, 135, is between the square root of 121 and the square root of 144, which is 11 and 12. Now, is 135 closer to 144 or is it closer to 121? Well, let's see here. It is 14 spots away. 121 is 14 spots away from 135, and it is 9 spots away. So I would say its nearest integer is 12 because 135 is closer to 144. So it's going to be closer to this 12 number. Okay. All right, take a look at the next page, example 2. So now we're going to estimate. Let's estimate to the nearest tenth. So here's how I do this. Again, I'm going to come over here. I know 9 squared is 81, and 10 squared is 100. Well, 83 is closer. If you look here, if I put this somewhere on here, it's going to be closer to 9 squared. So what's in between 9 and 10? Well, I have 9.1, 9.2, 9.3, blah, 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 all the way up to 10. So I know it's going to be closer to 9 than it is 10. So I'm going to choose an estimate like 9.2 or 9.1. So you're just kind of guessing here based on how close it is to the whole number. Okay, take a look at the check. Square root of 106. So again, I know I have a square with an area of 106. What's a smaller square? Perfect square, that would be 100. What's the bigger square? Well, that would be 121. So this is a side length of 10. This is a side length of 11. So does 106 appear closer to 100 or does it appear closer to 121? Well, I would say it's much closer to 100 because here it's only 6 spots away. Here it's 15 spots away. So I would take a guess, something like maybe 10.2, 10.3 would be my decimal value guess. So here's what I'd like you to do. Take your calculator, enter the square root of 106. Now again, we're not talking about cube roots, we're talking about square roots. So you're going to hit clear on your calculator. You're going to hit the second button. Then hit the x squared button. So you should get something like this. When you enter 106, if you don't get a decimal value, hit the conversion button, you end up with 10.3. So that's actually not a bad estimation there. So pretty good estimation. All right, so cube roots are the same exact thing. So take a look at page 104. So now we have the cube root of 320. So what I'm going to do over here, and you should do the same, is I'm just going to list some of my cubes here. So I'll start with 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. And 7 cubed is 343. Okay. So all you're doing is you have a cube with a volume. So if I drew a cube, boom, 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 it has a volume of 320. The edge length would be the cube root of that. Well, the greatest perfect cube less than 300 would be this 216. So the cube root of 216 is 6, so that would have an edge of 6. The least perfect cubed greater than 320 would be 343. So the cube root of 343 is 7. So I know this edge length has to be somewhere between 6 and 7. So what is it going to be? Is it going to be 6? Or are you going to guess 6 or are you going to guess 7? Well, where's 320 compared to these two numbers? Well, it's only 23 spots away from 343, and it's over almost 104 spots away from 6. So it is much closer to 7. So my integer guess would be 7. That would be its nearest integer because 320 is closer to 343 than 216. Okay, so let's scroll on down to 104. So here I have the cube root of 151. So if you want to do the pictures, I like the pictures. So I would draw a cube with a volume of 51. So what's that going to fall between? Okay, so I'm just going to come out here and put a few of them. So let's see here. 3 cubed is 27. 4 cubed is 64. Oh, I can already tell it's going to fall between those two guys. Okay, so I know that the smaller cube is 27. Well, this has an edge length of 3. The bigger cube is 125. This has an edge length of... Oh, I messed up. That's 64. Sorry, scratch that. So that's 64. I went up by 1. So that's going to have an edge length of 4. So it's between 3 and 4. This edge length of this shape is going to have an edge length between 3 and 4. Well, is 51 closer to 27 or is it closer to 64? Well, let's see here. It is 14 spots away. 27 is 14 spots away from 51. And 13 spots away from 64. So this one's really close. This is almost like halfway between, but it is closer to 4, so its nearest integer would be 4. Okay, and we can also estimate the decimal value. Now, when they say truncating, all they're asking you to do is knock off all of the decimal values that you want to truncate or get rid of. So again, truncate means get rid of values, get rid of decimals. Okay, so if I wanted to take the square root of 12, so if you entered square root of 12 into the calculator, it's not a perfect square. You're going to get this big, long decimal that's going to keep going on and on forever. It's irrational. It's irrational. It doesn't repeat, doesn't end. So to truncate it to the nearest tenths, just get rid of them. So this becomes 3.4. Boom. If I wanted to truncate this to the hundreds, well, I'd get rid of all the numbers up to the hundreds. So this becomes 3.46. And then finally, if I want to truncate it to the thousands, well, you just get rid of all the numbers after the thousand spot. So that's what truncating means. It just means get rid of all the decimals to where you don't want any more decimals. Okay. All right. What I'd like you to do is, take a look at the pause and reflect. So go ahead and write this number down. Let's say I want to know what is the cube root, what integer is the cube root of 100 closest to. So go ahead and write that down. So what does that mean? Well, that means I have a cube with a volume of 100. So what is that closest to? Well, what's the cube that's smaller than that? Well, that would be 64. So that would have an edge length of 4. What's one bigger than that? Well, that would be 125. It should be a 1. 125, which has an edge length of 5. So is 100 closer to 125? Well, it's only 25 spots away. And how far away is 100 from 64? That is 36. So the integer that this is closest to is 125. Okay. Now, we can also estimate decimal values the same way, but actually we're not going to do it. Let's just practice a couple ones with square roots. So we're no longer going to do cube roots here. Write down this problem. So let's talk about a decimal value for the square root of 200. Okay, so that means I have a square of 200. Well, what's the smaller perfect square here? Well, that's going to be 196, which has a side length of 14, and 225, which has a side length of 15. Again, if you don't like the pictures, if you could do something out here like 12 squared, 13 squared, 14 squared, 15 squared, well, that's 144. 169, 196, and 225. This is another way you can do it. You could say 200 falls between 196 and 225, and what's it closer to? Well, 200 is much closer to 196. So if I had 14 and 15 on a number line, well, that would mean I'd have 14.1, 14.2, 14.3, 14.4, all the way up to 14.9 until I got to 15. Well, is 200 closer to 196 or 225? It is much closer to 14. So that means I need to pick a number over here that's much closer to 14. And it is almost on 196. So I would choose here 14.1. That would be my decimal value. And again, what I would do at this point is grab a calculator just to check my estimation. So take the square root of 200. When you take the square root of 200, you actually end up with 14.1. So that is a good estimation there. Okay, so here again is all about estimating non-perfect squares. So these all end up being irrational numbers. Non-perfect squares are irrational numbers. So what I'd like you to do is go back to Schoology, follow along in Schoology. There are also the squares and cubes up on the front board if you want to copy those down. You should already have them in your book somewhere, but in case you don't, feel free to copy those down. All right, go ahead and follow Schoology, and good luck.